continuing on with Unit 1 material, and we're going to take a look at transformations. Now we're going to look at primarily at quadratic and an absolute value, because when we do linear transformations, it doesn't visually strike out as much as these two functions do. So let's go ahead and take a look at a quadratic, and again my quadratic parent function is just y is equal to x squared, or f of x is equal to x squared. So what we do here is, in this form, we want to look at what A, B, H, and K do. So A is my vertical compression or stretching. Also, we can put a -1 in front of that, and that's going to reflect it across the x-axis. My H will be my horizontal translation, left and right. My K is going to be my vertical translation, up and down. What is missing is a B. This B is my horizontal compression or stretching. Also, when it is -1, it reflects across the y-axis. So our first example here is we're taking our parent function and we're translating it into this statement right here. Now, one way I could have wrote it was like this. I could have done g of x is equal to -3 x minus 2 squared minus 4. One of the advantages of this is that I know that g of x is a translated form of this f of x. We just got to make sure that we know what our f of x is, which is x squared. You'll see that in the book quite frequently. So what did we do? Well, let's list them all. Well, the first thing that strikes out is I have a negative right here, so I reflected it across x-axis. It opens down. And the next thing I notice, and these are separate things because that's a -1 times a 3. That -1 serves a purpose, that 3 serves a purpose. I vertically stretched it. And I'm a little bit messy on my writing, by a factor of 3. So let's take a look over here, and here's my parent function. And by vertical stretching, all I did was say this is y is equal to x squared. I just made it more narrower, and it shoots up a little bit quicker. So I kind of stretched it, and that's y is equal to 3x squared. And of course, by flipping it over, I did that. Okay? So back to what else we did. Well, we translated it. We translated it twice. We have h, which is equal to 2, and k, which is equal to -4. So I went 2 to the right and 4 down. So I translated it 2 right, and I translated it 4 down. Okay? And I can do a quick sketch of my graph. Here's my x and y axis, drawn perfectly, of course. And what I did is I reflected across the x-axis. I stretched it, translated 2 right, 4 down, so it's going to look something like this. Okay? Kind of narrow and down. All right, let's go ahead and take a look at the next example. And this was off your homework, so this one is a little bit more straightforward. Let's take a look at everything that happened. First thing I notice is that I have a -1 in front of this, so that's going to reflect across x-axis. Okay. Next thing I notice is that my h is 7, my k is 8, so that's going to basically be a symbol translation, 7 right and 8 up translation. Okay. That's pretty much what we're looking for on these type of problems. Now, sometimes we can say, take g of x and translate it even more. So I can say, well, we're going to do it 5 to the right and 7 down or something like that. You just rewrite it. Let's take a look at this visually. Because when we look at graphs, we want to know what's going on. Now, here's my function right here. Now, I can easily complete the square and get this into my x minus h squared plus k form if I wanted to. But I'm not going to bother with it because they give us the vertex right here on the graph. So I can do this. I can do f of x is equal to, and I have a 1 right here, and it's positive, it opens up, so I know I have my x minus h. Well, I went over to the right 2, so I'm going to do minus 2. And I went down 9. Of course, I only allow one sign per term, so that would just be a -9 right there. Now, my parent function for my absolute value is just simply that. And my parent function, of course, would look kind of like that-ish right there. Okay, so all we did was we moved it over by -4, up 3, and reflected it. So if I wanted to, I should actually call this g of x, but what the hey. I have that. Now that's going to be an x plus 4. And that is going to be up 3. All right, so that is it for transformation basics. It's going to get a little bit more complex as we move into the course, but I'm going to go ahead and get this uploaded and on to the next video.